Continuing on, and so far 1 through 13 odd, and you're going to get the rest at the end. This is a table that's provided in the book. You know what? Let me make this look a bit nicer somehow. That's not working. Let me get rid of that. And instead, there and there. That's better. And let me make that look nicer. I'm into these things. I know you guys don't care much, but I do care. There it is. Much better. So now the calculus of this, I'm going to derive one of those four. You could derive all of them. The derivative of inverse tangent is 1 divided by square root of 1 minus x squared. Derivative of cosine, inverse cosine is negative 1 over square root of 1 minus x squared. And derivative of inverse tangent is 1 over 1 plus x squared. The red, that upper red, derivative of inverse sine, cosecant, inverse cosine, inverse secant is provided on your test. You don't need to memorize. You do need to memorize the derivative of inverse tangent because this integral comes up a lot more than you like, and you really want to get that out of the way. I want to derive one of those for you. Normally I ask the students which of those do you want me to derive, and they pick. Since we're not in class, I'm going to pick for you. Let's say I want to take a derivative of inverse sine of x. Let's say I want to take the derivative of inverse sine of x. What I do, I'll say consider y equal the inverse sine of x. And I want to find the derivative dy dx, right? That's what I'm trying to figure out. What's the derivative of this? Wouldn't that mean that x equal the sine of y? Because I don't know how to take a derivative of an inverse. And now if I take a derivative with respect to x of both sides, wouldn't that get me? The right side will be a 1. The left side, wouldn't that be the cosine of y times dy dx by the implicit differentiation? Wouldn't you say dy dx would be 1 over the cosine of y? Well, think about it. If I take this, and I say the sine of y equal x, I'll give you a hint. Doesn't that mean that we're talking about a triangle? There's y, the opposite over the hypotenuse. Doesn't that make this the square root of 1 minus x squared? And isn't this right here? Isn't that right here 1 divided by the cosine? What's cosine? Isn't cosine the adjacent over the hypotenuse? So, if I let y equal the inverse sine, what's dy dx? There it is. So what's the derivative of inverse sine? There it is. You could derive all of them that way. Now, have this next to you as you're doing these problems. Make sure to memorize that derivative of inverse tangent is 1 over 1 plus x squared. And the rest of the section is nothing more than practice problems with some quotient rule, product rule, implicit differentiation, all of that. Find the derivative of the function, simplify when possible. What's g prime? Derivative of arc cosine is negative 1 over the square root of 1 minus the square of this. So if you square root of x, I'm writing that for your notes, by the chain rule times the derivative of square root, which is 1 over twice the square root of x. Now on a test, if I say take a derivative, do not simplify, there's the answer. And that's normally what I ask you to do on the test. If I want to take a derivative of inverse tangent, well, y prime would be 1 over 1 plus whatever the angle is squared, and it's right there, times the derivative of the angle by the chain rule. Again, on a test, you're done right there. You want to match it with the back of the book. Those answers will look slightly different. x squared. And here, that would equal 2x over 1 plus x to the fourth. The tough part is not taking the derivative. The tough part is going back, which is the next chapter. And if I want to take a derivative of this, derivative of inverse cosine is the same as inverse sine, except with a minus. So that's negative 1 over the square root of 1 minus whatever the argument is squared, times derivative of the argument, that's 1 over the square root of 1 minus whatever that argument is squared, and derivative of t is 1, so we're done right there. Number 30 and 34 are fun problems, if you know what I mean. If I want to take a derivative, that is 1 over 1 plus square the argument times the derivative of a radical is 1 over twice the radical times the derivative of the radicand, quotient rule, derivative of the top times the bottom, minus the top times derivative of the bottom, all over the bottom squared. And believe me, if you simplify this, the answer would shock you. I don't have time to do that. You do. That's the difference between a teacher and a student. Power of being a teacher, you could always say, oh, as an exercise, try that on your own. Same deal with number 34. If I want to take y prime, derivative of inverse tangent is 1 over 1 plus the square of the argument times the derivative of x over a is 1 over a plus, here you have a couple of options. You could expand that, you could leave it as is. Derivative of a log is 1 over the argument, whatever that is, times derivative of an argument, that's 1 over twice the square root of x minus a over x plus a, times the derivative of the inside, which is the quotient rule, derivative of the top times the bottom, minus the top times derivative of the bottom, all over the bottom squared. This one simplifies a lot quicker because those radicals cancel out. But again, you could leave the answer like that on a test if I say do not simplify. I do want to warn you, I do say simplify sometimes. So on the homework, you simplify all the way. On the exam, that's a different story. I want to take some limits. Well, let's see how this works. The limit of an inverse trig function is the inverse trig function of the limit. What is the limit as x approaches infinity? You did this when you did horizontal asymptotes. You divide by the highest power term of the denominator, which is x squared. So that will be 1 over x squared plus 2, 1 over x squared plus 1. Limit as x approaches infinity of that will be 0. So this is the arc cosine of 1 over 2. And if I wanted to know what the arc cosine of 1 over 2 is, that is actually 60 degrees, or pi over 3. Right? If ever in doubt, 1, 2 radical 3 will do the trick. Alright, and if I want to take the limit of the inverse tangent of natural log, let me start with natural log. How does that graph look like? And as t approaches 0 from the right, that approaches negative infinity. Now I'm looking at an inverse tangent graph. Inverse tangent graph looks like and as the angle approaches negative infinity, what does that approach? There it is. And now we want to go and memorize another interval. something. That's why I need you to know that the derivative of inverse tangent is 1 over 1 plus x squared, because I'm assuming when I say, what did you take a derivative of to get 1 plus x squared? You're going to tell me I must have taken a derivative of inverse tan of x. And the reason I need you to memorize that, because it comes up a lot more than you like. Now I want to derive this. There are 4 integrals that come up a lot more than you like. This is one of them. So if I look at the integral of 1 over x squared plus a squared dx, I would factor out, because I want that to be a 1, I would factor out an a squared. That will make it x squared over a squared plus 1 dx. I would factor out an a squared completely and say that is dx over 1 plus x over a squared. And if I let u equal x over a, then du is dx over a, and dx will be a du. So this integral becomes 1 over a squared, the integral, and let's see how that works. There is a line, there is a 1 plus, there is a u squared. I took this u and I took that x over a and put a u in place, and dx is going to be replaced by a du. That cancels one of those, so that's 1 over a, the integral of du over 1 plus u squared. Isn't that 1 over a, the inverse tangent of u plus c? And if I substitute u back, what do I get? Isn't that 1 over a, the inverse tangent of x over a plus c? So either you derive this every time, and you see this about 20% of the time in the remainder of the course, or you memorize it. So I need you to memorize 4 integrals. The first one was the integral of tan of x dx. That was natural log of absolute value of secant of x plus c. I needed to memorize the integral of 1 over x squared plus a squared is 1 over a, the inverse tangent of x over a. And there are 2 more that are coming your way. Now, if I look at the last portion of this test, of this section, we're asking, can you integrate the following? Well, hey, I know what that is. That is 6 times the inverse sine of p, evaluated from negative 1 over radical 2 to 1 over radical 2. That is 6 times the inverse sine of 1 over radical 2 minus the inverse sine of negative 1 over radical 2. And that turns out to be 6 times, this is pi over 4 minus a negative pi over 4. So that's plus. That turns out to be 6 times pi over 4 plus pi over 4 is 2 pi over 4, which is pi over 2. And that turns out to be a 3 pi. And if I look at this problem, right, I would say, well, you know what? This looks like 4x squared. If I let u equal 4x, du will be 4dx. So this becomes the integral. The 1 is there. I'm going to square. The 4x, I let that be u. And the dx is really what? Du over 4. And I'm going to change the limits on the integral. I talked about that last time. If you put a 0 in for x, 4 times 0 is 0. If you put in radical 3 over 4 in, the 4's cancel out and you're left with radical 3. And this will become 1 over 4. What do you take a derivative of to get 1 over 1 plus u squared? Inverse tangent of u, evaluated from 0 to radical 3. That will give me 1 over 4 times the inverse tangent of radical 3 minus the inverse tangent of 0. That turns out to be 1/4. This will be pi over 3 minus 0, which is pi over 2. and I have, let me check. I need about another 5 more minutes, so I'm going to continue on in this video and make it 20 or 20 some minutes. If I look at this problem, what do you let u equal? You let u equal the denominator, right? Well, if you let it be the denominator, it's a problem because du wouldn't be sine of x dx, or the power in there, which is the cosine of x. And this is now you're going to start thinking this way. Let me start that right now, this process. I know you haven't thought that way. You want to start thinking, this is my du. What do I take a derivative of to get sine, cosine? Do I see a cosine right there? One more time. You want to start thinking of, this is my du. Here, this is my du. What do you take a derivative of to get sine? You take a derivative of cosine. That's how you start. You say, okay, I have a cosine, so I'm in good shape. Du is the sine of x dx with a negative. So I could switch that. This is the integral, 1 plus, and if I put that u in, that becomes a u squared, and this is simply negative du. I could take the negative up front. I'm going to change the limits on the integral. If I put a 0 in, cosine of 0 is 1. If I put pi over 2 in, that's a 0. So this is negative inverse tangent evaluated from 1 to 0. That's negative inverse tangent of 0 minus inverse tangent of 1. That is negative a 0 minus pi over 4. The answer would be pi over 4. And there it is. And if I go for number 68, again, glancing at this, I might not get it. What do you take a derivative of to get e to the 2x? You let u equal e to the 2x. That's the only way. Du will be e to the 2x times 2 du. Well, guess what? Du will be 2e to the 2x dx. This is right there. So I could get rid of that 2 and replace that up there by du over 2. That's not a problem. The problem is, do you see how I'm going to be able to fit this into this? I'm going to say this is e to the 2x squared. If you let u equal that inside, that becomes u squared. And 1/2 du, wouldn't that be 1/2? And isn't that right there inverse sine of u plus c? And what would that be? If I go to my u, that is e to the 2x. There it is. And one more to go. Again, you really want to start thinking that way. This is the class of integration. This is a must. If I look at, what do you take a derivative of to get x? You take a derivative of x squared. So du is 2x dx. This part is right there. It's off by a simple 2. Off by a constant is not a problem. So I know what to replace that with. Well, what's left? I need an x squared out of that. And this is something that's going to happen a lot. So this is the integral of 1 plus u squared. And the top is simply du with a 1/2. And isn't that 1/2 inverse tangent of u plus c? And what was u? U was x squared. At any given time, you could take a derivative of this. You should get that. And that's really easy and quick. I want to set up number 47. It's on your homework. Suppose this is 3 meters, 3 feet, 3 miles, whatever it is. This is 2. Where should the point P be chosen on the segment AB so that maximize the angle theta. Well, I want to maximize an angle. I know how to do that. I'll take a derivative and set it equal to 0. If I look at this first triangle, if I call this beta and this gamma, wouldn't you say beta plus theta plus gamma equal pi radians? And if I look at this triangle, wouldn't you say if this is x, this is 3 minus x? So this is a triangle. If I have the angle beta, that's the opposite and that's the adjacent. Wouldn't you say tan of beta equal 2 over x? And what would beta equal? Isn't that inverse tangent of 2 over x plus theta plus? If I go to gamma, look at this right triangle. Isn't this the opposite? This is the adjacent. Wouldn't you say tangent of gamma equal the opposite over the adjacent? So wouldn't gamma equal the inverse tangent of 5 over 3 minus x? How do you find the maximum of an angle or a function? You get the function by itself. And you take a derivative, set it equal to 0, right? You take theta prime, set it equal to 0, where's it undefined, and do all of that work. And wouldn't that be when this is 0 minus 1 over 1 plus 2 over x squared times negative 2 over x squared minus 1 over 1 plus the angle squared times the derivative of that. So this is like saying 5 times 3 minus x to the negative 1. A derivative of that would be negative 5 into 3 minus x to the negative 2 times negative 1. That becomes a positive. So that's 5 over 3 minus x squared. Clean that up and finish the problem. I just want to check if the homework is accurate. And there's the homework. Don't forget the first part, 1 through 13 odd. And that concludes this section.